Today we're talking about the mechanics of breathing, and this is for SBI3U. Mr. Roddy here. A couple of key things when we talk about breathing. There's two aspects of it. There's the inhalation. Okay, and that's the process by which air enters the respiratory system. Okay, and inhalation is an active process. Which means energy is required. Okay, and then the other side of the coin is when there's exhalation or exhaling. Again, the air leaves the respiratory system. Okay, and this is a passive process. Basically, your body is relaxing when you exhale out from there. Okay, so inhalation is active, exhaling is passive. Okay, and the reason inhaling and exhaling works and why the lungs fill and that's primarily because of the change in air pressure and the ambient and surrounding air pressure. Okay, so we're going to go to the next slide, and the next slide I'm just going to try and explain to you sort of what I mean by the air pressure changing, okay? So I'm going to give you different scenarios. In the first box, we have 6 particles of air in that box, so it has a certain amount of pressure in it. If I increase the box size, but I don't increase the amount of air inside, what I've done is in this box, the air pressure has decreased. Okay? So in box B, the air pressure has decreased. Whereas in box A, that was your starting pressure. Okay? So if you think of a balloon, okay, let's think of a balloon for a second. When you inflate the balloon, okay, and you tie it off, okay, so we've got the balloon that's tied off, there's a certain amount of air that's been pushed into that, and there's a pressure pushing outward, okay? And as the balloon is inflated, that pressure pushing out is less than the pressure pushing in. Okay, so the ambient air around has less pressure than the sealed balloon has on the in the inside. Okay, if I were to take and cut a hole into the balloon, what will happen is because the air pressure inside is greater than the outside, the air will exit to try and equalize, because air always travels from high air pressure, from a higher concentration of air pressure to a lower air pressure. So when you look at it, you want to make sure that you understand that if something's going to change in air pressure between two locations, one will head in from a higher air pressure to a lower air pressure. And then if we start looking at the physiology of our internal system, we have basically two inflatable balloons that are our lungs attached to a nasal and oral cavity that can open and close. And so if you're not doing anything, the air pressure on the outside is going to be the same as the air pressure on the inside. Okay? So there's no difference as long as it's open. Surrounding this is the pleural cavity. Okay, and it's a sealed bag essentially, in which it's surrounded by the ribs and the intercostal muscles. And at the bottom, you have the diaphragm. And it's got a silent G. Okay, so diaphragm has a silent G, diaphragm. Okay? And it has its own internal air pressure. Okay? So as long as the air pressure stays the same inside and out, nothing is going to change. But when you inhale, what happens is the intercostal muscles grab the ribs and basically lift them up, so you're up and out, and the diaphragm contracts and drops down, and so what happens is this sealed bag becomes larger. Okay? And it's inside, you have the same amount of greenery as you had before, so the inside, as it increases, the pressure inside decreases. And as that air pressure decreases, what happens is the air that was outside, which was equal in pressure, all of a sudden seems to be a higher pressure. And what happens is the air will come rushing into these lungs, and the lungs increase in size to take up that space that is now available to create the same amount of pressure on both sides. Okay? And so as the air comes into the lungs, it's drawn in. When you exhale, when it exhales, this pushes back. Okay? And when it pushes back, it creates the green dots inside to have higher pressure because it's a smaller space. And lo and behold, the air then gets forced out of the lungs and back out through the trachea and outside. And so basically, when you inhale, the pleural cavity that is in the red, okay, the pleural cavity increases in size, and so the air pressure decreases in that cavity. The ambient air that was in the lungs, well, it now has a higher pressure than the pleural cavity, so the air will come rushing in, and it will inflate and take up more space where it normally wouldn't be. Okay, so that's basically a quick little blurb about inhaling and exhaling and how the air pressure changes around it so that you will get the inhaling and exhaling. One little thing that I'm just going to talk about is when you look at a person, okay, they have their ears, okay, and their mouth and their nose. Okay, we've got these happy persons, okay. There are tubes that run to the back of the throat for your ears and your nose, okay? And that's your eustachian tube, okay? And basically, if you were in Hamilton City and you were driving downtown, and then where the school is, which is up on the mountain, we'll call this Westmount, okay? If the car's driving up, as you go up in altitudes, the air pressure decreases, okay? Whereas down here, there's a higher air pressure the closer you are to the center of the earth, okay? And so as the car is driving up the hill, sometimes your ears will pop. And the reason it's popping is because the ambient air pressure that was in your lungs is now being expelled because there's less pressure out here and you feel the air popping through your ears. So just as a sidebar, that happens, okay? I'm going to cut it there. If you have questions, please make sure you email me or contact me if you have more questions.